here we have third theorem, perpendicular drawn from the center to the chord bisect the chord. So what does it mean? Here we have a diagram, that is a circle we have, and there is a chord. We can take anywhere, but generally we'll take for our convenience, we'll take here, and there's a center. Now it says that from the center, if we'll draw one perpendicular, it should be perpendicular, means this should be 90 degree, because height should always be at 90 degree. So here we're taking OM perpendicular to AB. Then what does this statement means? This says that if OM perpendicular to AB, then AM equals to BM. That means if your AB is 6 centimeter, then AM 3 centimeter, BM 3 centimeter. This OM bisect AB. So what we have given, so we're going to write here. So given, they have given here OM perpendicular to AB. This one they have given, perpendicular drawn from the center to the chord. This one they have given, OM equals perpendicular to AB. This one they have given. We need to prove. What we're going to prove? We need to prove that bisect the chord, that is AM equals to BM. We need to prove this one. So for this, what we need to construct the two triangle, because we need to congruent the triangle, and then we'll get our proof. Here construction is compulsory. So we go for the construction. What we're going to do? Join OA and OB. We'll join here. Join it. OA and OB. Now our target to prove these two triangles are congruent. So you can see here OA equals to OB, radius of a circle, OM common, and angle OMA equals to OMB, each 90 degree. By RHS congruency rule, we can say that these two triangles are congruent, and then by specificity we can say that AM equals to BM. So here we're going to write the presentation. So proof, here we have in triangle OAM and triangle OMB, OA equals to OB. Sorry, here we need to write OBM. Okay, order is very much important. So OA equals to OB. Next is OM equals to OM. That is common. So you need to mention the reason in the bracket. Otherwise, you may lose the mark. Okay. And the third one, angle OMA equals to angle OMB, each 90 degree. So therefore, we can say that triangle OAM congruent to triangle OBM by RHS. If these two triangles are congruent, that means by simplicity we can say that AM equals to BM. This only we need to prove. Proved. And converse of this one, we're going to see the converse. That is the theorem 4, converse of it. So in converse, what they are saying, if the line segment drawn from the center bisect the chord, then OM must be perpendicular to AB. This one you need to prove. That means converse of it. Converse means this one has been given. Now we need to prove this. Okay. So here we're going to draw the same diagram. There will be no changes in the diagram. So we'll mention here. But this time, yes, we have 90 degree because height always be your at 90 degree. So given, we'll mention here, given that is AB, not AB, AM equals to BM. This one has been given. We need to prove that is OM perpendicular to AB. Okay, that one we need to prove. So we cannot take here perpendicular. Okay, remember, we cannot take the box here because we need to prove this part. So we'll just keep it OM. Okay. Now next construction, we'll join here. Join OA and OB. Join it. After that, we're going to prove these two triangles are congruent. Let's see. So in triangle OAM and triangle OBM, so these two are common. You can see here OA equals to OB and OM equals to OM. So first one is same thing, that is a radius of a circle. Second one common, you can see here. And the third one, this time it has been given, that is AM equals to BM. It is given as it bisect. Now therefore we can say that triangle OAM congruent to triangle OBM by which criteria? SSS criteria. By SSS criteria we can say this triangle are congruent. Therefore angle OMA equals to angle OMB by CPCT. But we need to prove that OM perpendicular to AB. But what we know that angle OMA plus angle OMB equals to what? 180 degree. Can you guess by which reason? Yes, linear pair. As you can see, there is a straight line and sum of these two angles must be what? 180 degree by linear pair axioms. So from 1 and 2, what we can see that OMA plus OMB can be changed by this, because both are equal. We can write here OMA. So if we add here, we will get 2 times of OMA equals to 180 degree, and this give you OMA equals to what? This 2 will be at the denominator here, we will get 90 degree. Therefore both are equals to 90 degree. This implies what? We can say that OM perpendicular to AB. If it is 90 degree, we can say that yes, OM perpendicular to AB. This we need to prove. I hope you people have understood. Thank you.